So what do? You factor, right? That's what you do anytime you see fractions where you're multiplying and dividing. You factor. So and you don't look at the whole thing. You look at this top part and say, well, what can I do? Well, I can factor an x out, and if I factor an x out, that's going to give me x squared minus 3x minus 4. And when I look at that, that's something I can factor, and that's actually going to factor as x minus 4 times x plus 1. So when I'm finished with this whole thing, this top is going to be x times x minus 4 x plus 1. All right. The bottom, well, you need to factor that, and that actually factors as, this is going to factor as an x minus 4 and another x minus 4. Right. Your success in doing anything that we're doing in this chapter all depends on how well you factor, which, I don't know if you've noticed, a majority of this semester has been geared towards factoring, because that's what you need to be able to do any of these problems. All right, next up, we look here. Well, factor that. Well, that's going to factor as x plus 4, x minus 4. What can I do there? Well, the only thing I can do here is factor out. I can actually factor out a 3x. When I factor out a 3x, I'm going to leave with x plus 1. So, step 1, factor. Now, once you get to this stage, it's not so bad, because now we can just start canceling things out. Let's see. This x plus 1 cancels this x plus 1. This x minus 4 cancels this x minus 4. This x minus 4 cancels this x minus 4. And this x cancels this x. And the only thing left on top is x plus 4, and the only thing left on the bottom is a 3. What I can remember, when I took Algebra 2, this is always kind of a satisfying type problem, because you start off with something pretty ugly, and you typically end up with something relatively small. Sometimes you don't. There's some times where pretty much everything cancels out. Okay, and this one's probably a little unfair, but maybe unfair on a test, but I don't think it's unfair to put as a warm-up. We do the same thing. Our job is factor. So, how do I factor the top? Well, I guess the first thing you do is you do that, multiply by the reciprocal. So we know we're going to do that. But I do want to look at this and see what I can factor. And the first thing I notice is I can pull a 6 out. And then I'm left with x to the 4th minus y to the 4th. Then, I'm not done. That's a difference of squares as well. And so that becomes x squared minus y squared times x squared plus y squared. And I'm not done yet either, because that's also a difference of squares. And so that gives me x plus y times x minus y. So when this whole top part of this first fraction is going to give me a 6. Then I have x plus y, x minus y, and then an x squared plus y squared. All of this was that part. And then next I need to factor this. And that's a sum of cubes. You see this is a sum of cubes? I've got x cubed plus y cubed. So since that's a sum of cubes, that's going to factor as a 2-part thing and a 3-part thing. So the 2-part thing is I drop the cubes. That's going to give me x plus y. What's left over here is this thing squared is x squared. This thing is y squared. You get the middle, multiply these together. This is the same. This is opposite. This is always positive. So step 1, take this and you factor as much as you can. Then we need to flip that. And go ahead and multiply by the reciprocal. That's going to give me x squared minus xy plus y squared over 3x. Can I go ahead and pull a 3 out? Does that make sense? I can just go ahead and pull a 3 out of that. And And so if I pull a 3 out of that, that gives me x squared plus y squared. All right. Now when you look at this, what can you cancel? So what cancels? All right, yeah, 3 goes into 6 2 times. What else?
X plus y.
Yep. X plus y's cancel. What else?
X squared minus 6y plus y squared.
Oh, that whole thing. Oh, that's nice. What else?
X squared plus y squared.
Whoa. A lot of stuff got canceled, didn't it? What's left? The x minus y and the 2. Is there anything left on the bottom? Technically, there's a 1, but we don't need it. So this whole thing simplifies to 2x minus y. All right. So, okay, why is this important? Right? I had 2 options as far as going through this material. I could rush through it. The problem is, if I rush through this idea of simplifying, it's going to hurt you for any math class you ever take. Because what happens when you see any kind of ugly math question, like I'm gonna say this qualifies as an ugly math question, right? An ugly math expression, right? Your job is to try to make things as simple as possible before you have to do anything with it. Like if this was an equation, like you had this and I set it equal to something and you had to try to solve that, that's very intimidating. But if you know how to simplify, setting this equal to some number and solving is not as intimidating. So this practice of simplifying is huge. And this is the course you learn it. This is the course where you're supposed to learn it. If you don't get it in Algebra 2, you're not going to get the practice in pre-cal. You're not going to get the practice in calculus. And what's going to happen is you're going to get ugly questions and you're going to be expected to simplify them, right? And if you can't simplify them, then you're just not going to be able to solve them. So that's why we're spending some time on this. All right, so what you have, so in OneNote, I sent out, you've got 8.1 and 8.2 practice. The instructions are, let's see, for 8.1, I had you do 1 through 21 odd, and for 8.2, I had you do 10 through 24 even. Forgot to write that on the page before I handed it out to you. So in 8.1, your assignment's 1 through 21 odd. For 8.2, it's 10 through 24 even. And we've got about 30 minutes left in class. That's what I want you to work on. Okay. I do need to do a couple of examples because while most of these questions are basically little extensions from what we've been doing the past 2 days, there are some that are major extensions, and I want to make sure you at least see the trick on how to solve them. All right? So, first, major extension looks something like this. So if I give you x squared minus y squared over y squared minus 49 all over y minus x over y plus 7. I'll give you a few seconds to copy this down. It's not on there. Sorry. Yes.
What did the second one say? Y squared minus what?
49, the marker's dying. And that marker's not doing much better. All right. So I call these complex fractions. Right? They're fractions, but they're way more complicated than just your regular ones, right? And years past, I may have called them layered fractions, like you have a fraction over a fraction. And at first, this may look really complicated until you realize that whenever you see a fraction, this thing in the middle is called a division bar. Okay? Like, there's sometimes I'll actually, when I'm teaching, I'll say 7 divided by 2, right? Because that's what a fraction is. It's 7 divided by 2. So whenever you see a fraction bar, right, that's actually a division bar. And we did that when we did the polynomials. We had something, some ugly polynomial divided by x plus 2. This means divided by. So what this thing actually means is x squared minus y squared over y squared minus 49 divided by y minus x over y plus 7. Everybody see how I got from here to here? Okay. This line means divided by. So all I did was, it's this divided by this. I just wrote it out like the way it's supposed to mean. And now this looks like problems that we just did. We know how to handle divided by fraction. We multiply by the reciprocal. So to solve this, first I recognize I have a difference of squares, so that's going to give me x minus y times x plus y. There's another difference of squares, that's going to give me y plus 7, y minus 7. When I multiply by the reciprocal, this is going to give me y plus 7 over y minus x. And now that I have everything factored, now you look at it and you ask, well, what can you cancel? So what can you cancel? Oh, y plus 7, those cancel. Okay, what else? This was sneaky.
X minus y, y minus x.
X minus y, y minus x. When you cancel those, what does it create?
Negative 1.
Right? We talked about, like, these do cancel. Like, these are almost the same. And so when you see that x minus y and that y minus x, they're almost the same, so they do cancel, but you have to remember it creates a negative 1. And you write down what's left. Well, see, the only thing left on top is that negative and that x plus y. And what's left in the bottom is the y minus 7. And there's my answer. So what did we do? We saw something ugly. We said, all right, it's this divided by this. So we wrote it out. And once it looks like this, then it looks just like the other problems. We multiply by the reciprocal. All right. So that was definitely a bigger step up than what we were talking, what I did Monday and Tuesday. The next example has to do with adding and subtracting. So if I give you 1 plus 1 over x over 1 minus x over y. So everybody needs to write this down. So, believe it or not, this is the same, this is in the section where we're adding and subtracting, because I'm adding a couple of things. Now, there are two ways to approach this problem. All right, I'm going to show you the long way and I'm going to show you the short way. Right? And my advice is don't write down the long way. Right? So the first way I'm going to do this is kind of the way I was taught in school. And the way I was taught in school is you look at this top part. And when I look at this top part, I've got to make that one big fraction. So in my head, I've got 1 plus 1 over x. To add those, I need a common denominator. This is over 1. I'm going to multiply top and bottom by x. This is going to give me x plus 1 all over x. So I've combined these two terms to make one big fraction. I'm going to do the same thing here. I'll write this, get a comment, this is 1 minus x over y. When I get my common denominator, I've got to multiply top and bottom by y, so this is going to give me y minus x over y. Here's my big division bar. And so now when I set this up, I'm going to end up with, this is x plus 1 all over x divided by y minus x over y. I'll end up with x plus 1 over x times y over y minus x. And I end up with y times x plus 1 all over x times y minus x. That's the long way. That's the way I was taught. Right? And if you want to do it that way, that's fine. Here's the clever way. The clever way is you look at this, and when you look at this expression, you think, I don't like fractions. Right? And what makes a fraction is the denominator. So when I look at this, if I could make that x go away, then I wouldn't have a fraction. And what I'm allowed to do, and what makes that x go away, is if I could multiply everything by an x. Now the way fractions work, you can do that. You can multiply the top by x. But the catch is, if you multiply the top by x, you also have to multiply the bottom by x. I guess while I'm looking at this, I also notice I don't like that denominator. So to get rid of the y in the bottom, guess what I need to multiply by? Y. So I'm going to multiply by y. But sort of the catch is, whatever you do the bottom, you got to do the top. Now look what happens. If I do this times this, that gives me an xy. When I do this times this, the x's cancel, and so I end up with a y. Okay, right? Sort of imagine you've got a little xy here and a little xy here. So the xy gives you this, the x's cancel, and gives you a y. And a similar thing happens here when I distribute this. Imagine there's an xy here and an xy here. 1 times xy is going to give me an xy. The y's cancel. When the y's cancel, I'm left with an x squared, so I end up with a minus x squared. And when you compare this answer to this answer, the only difference is I think things have been factored. See, if you distribute that, you get this. If you distribute that, you get this. All right. Let's look at it again. Ready to write that down. Is everybody written it down? All right, now let's look at the top. What do I need to multiply the top by so that I get rid of all the denominators? Are we okay with xy?
Yes, sir.
Does that make sense? Do you see if we multiply the top by xy, that's going to get rid of, because you imagine the little xy here, the x's are going to cancel, the xy here, the y's are going to cancel. But the rule is, whatever you do to the top, you got to do the bottom, right? And so now let's see what we have. when you distribute that xy on top, what's left on top? Everybody get a y plus x? Because imagine there's a little xy here, a little xy here, the x's cancel, the y's cancel, so we're going to end up with a y plus x. That top looks a lot nicer now, doesn't it? Now what happens when you distribute this? What do you get? What happens when you don't have to, it doesn't go to both, it just goes to this one.
Y minus x.
So this is going to give me y minus x times the x plus y. Things got real simple after one step, didn't they? Now what's left? Can we cancel anything?
Yeah,
What can we cancel?
y plus x and x plus y.
Right. So y plus x and x plus y, does that create a negative 1? It only creates a negative 1 when there's a minus. Because y plus x and x plus y are the exact same thing. Now, since everything's canceled, we end up, we're going to end with a y minus x on the bottom and a placeholder on top, which is a 1. All right, so here's what I want you